Welcome to our next session in highway engineering. I hope you know I will give you a in short in transportation engine. Give me a second. So I'm checking my pen. Okay. So in short, we are in transportation engineering. Under that, we are in highway engineering. Under highway engineering, we are in geometry design chapter. Under geometry design chapter, so we have completed up to site distance. We are under a topic called horizontal curves and super elevation. Okay, so this will be somewhere around third or fourth chapter, I think. So welcome. So far up to previous session, we have completed around this site distance, and also we have given a detailed introduction about cross-sectional elements involved in the our highway roads. Okay, so so let's go to the horizontal curves. Okay, so I will give you in short introduction before going into the detail in this slides and figures. So if you remember, in a straight road, if you are taking a straight road, okay, so the radius of the straight road is, or a radius of a straight line is always infinite. Correct, the radius of the road is always infinite. So if you remember our school physics formula to estimate the centrifugal force, so this will give you centrifugal force developed will be 0, right? So there won't be any centrifugal force if you are traveling in a straight road. Okay, so I hope I made you clear. So when you are traveling in a straight road, so there won't be any lateral forces or any centrifugal forces to push you down. So obviously there won't be any problem. So when you are traveling straight road, there no issues. Okay, but when you are traveling in a horizontal circular curve, horizontal roads, okay, when you are traveling something like this, so when you are traveling in a horizontal road, obviously now you got some radius, correct? So what is happening there? Now in that case, we know F equal to centrifugal force can be given by mv square by r, and since the r, now there was the radius was infinite earlier, now we got some radius, something around 300 or 400 or 100. So now we got some radius. So since we got some radius, so there will be a centrifugal force. So understood? So since there is a radius, there will be a centrifugal force. Centrifugal force is nothing but, you can see the figure above. I am circling. This centrifugal force is going to act on your vehicle. Okay, so what this centrifugal force will do, this will make your vehicle either, because of the sudden introduction of the centrifugal force, this vehicle can make you either to overturn, or actually this is slide, okay, or skid. So there are two terms, common term, because of the centrifugal forces, either your vehicle can overturn or it can skid. So these two, there are two possibilities are there. Okay, so this lateral forces. Okay, so what to do to avoid overturning or to avoid skidding? So I hope I made you clear. So in horizontal curve, there will be a radius. Since there is a radius, when your vehicle is going to circle around it, since your vehicle is making a circle, so there is two things possible because of the sudden introduction of the centrifugal force. Either your vehicle can overturn, or either your vehicle can skid. Okay, so to avoid overturn, what you should do, you see, consider the figure ago. I will draw a separate figure here to make it more clear. So consider there is a vehicle. So consider there is a horizontal curve is about to come, and this is a point. Consider the W is acting at the center, and centrifugal force is acting in this direction. Okay, I hope you, as per your ideas, you should know that centrifugal for this point, the COG. Okay, the point will be COG, means center of gravity. Okay, that is a point we will all the force the resultant will be acting. Okay, so the weight of the vehicle is coming from there, that is at a distance of height h. Okay, and consider the distance in this direction between these two. So the distance between the two vehicles center to center is approximately, let us take like or width of the vehicle, okay, let us take like B. Okay, so who will, to avoid overturning, consider my vehicle should not overturn, means the resistance developed should be greater than driving, right? The resistance developed to avoid overturning should be greater than driving. Who is resisting? Obviously my weight is resisting. It is a moment, right? So force into distance into B by 2, correct? So you can see the W into this distance, it is something like your mark into this distance, correct? I am consider I have to make it clear. I am finding a moment with respect to, see, to overturning point will be at the center of one vehicle's tire. So consider there is a vehicle tires or something like this. I am finding moment with respect to this point. Okay, understood? So because overturning is, if there is an overturning, either it is outward overturning or inward overturning, it will be with respect to some tire point, right? The center of the tire point. So the force into distance, I'm this is what I am going to resist, okay, with respect to my weight into that distance should be greater than or equal to, who is driving, who is making you to fall, is nothing but the centrifugal force into its height. Okay, so this is the formula you should know. If you see, I have to make it little clear again. Okay, please note down this one. I have to erase, or you can pause the video and come back. Okay, I have to erase everything. So now we know W into B by 2. So you can see even in this figure W into B by 2. Okay, you can take a rotational point either at A or B. If it is greater than P into H, okay, P into H, my vehicle will not overturn. So we know, as per the concept of Newton's law, W can be written as mg, correct, into B by 2, and it should be greater than, what is centrifugal force? It can be written as mv square by r. Okay, this also you know as per physics, into 2. So if you cancel each other, and if you bring the vehicle dimension on one side, B by 2h, you can see everything is vehicle dimension. B is nothing but the center to center distance between the tires, and h is the COG distance of the vehicle. If that is greater than V square by GR, then obviously the vehicle will not overturn. Okay, so that's what I have written here. This V square by GR, which is on right side, can be also said as centrifugal ratio, because take P by W. What is P? Centrifugal ratio, right? You can write mv square by r divided by mg. So cancelling you will get V square by GR. This is also one way of getting that V square by GR. Okay, so if you take both centrifugal in terms of centrifugal ratio, you can see V square by GR is the term. You can, what is V? V is the velocity of the speed of the vehicle, right? At what speed the vehicle is going around the curve. What is R? R is the radius of the curve. So all the curve properties and the vehicle's speed properties coming on right side, vehicle's body dimension is coming on left side. Okay, and P by W is the term, is like an applied force, like an applied moment. Okay, the guy who is driving you, making you to fall down. So that is that V square by GR. Our job as a highway engineer is to, in this we have to resist, or we should provide a body dimensions or something to be much more than V square by GR, such that we won't overturn. Okay, so this is the first concept. If you take the second concept, so to avoid skidding, you can see this figure is exactly we can use for skidding. To avoid skidding, obviously the force generated as a resistance, skidding means it's a lateral force, right? So the resistance developed should be, if it is greater than the resistance developed, if it is greater than driving force, like a force, okay, resisting force divided, if it is greater than or equal to driving force, there won't be any skidding, correct? So how to resist? So the resisting force is obviously given by the friction. Okay, so the friction, there are two tires, so two, you can type it as a, you can write like this, tires, this first friction, I hope you know friction formula. Okay, F into area, you can see the figure, plus friction into F is, small f is coefficient of friction. Okay, so if it is greater than, who is driving? This guy P is driving. Okay, so you can take F common, RA plus RB you can write as a W if it is greater than P. Okay, if coefficient of lateral friction, if it is greater than or equal to P by W, then there won't be any skidding. So I hope you remember what is coefficient of what is the P by W. Just now in 2 minutes before we have discovered that it is nothing but V square by GR, correct? So again the same V square by GR is coming here. If your coefficient of friction, whatever friction in the road is available as per IRC, that number is fixed as a 0.15. Okay, they are recommending you to use the term 0.15 or lesser than that maximum. If your V square by GR ratio, if it is less than 0.15, then there won't be any skidding. If the speed what you are traveling with that in that radius, if that ratio is very high, then obviously the skidding will happen. Okay, so these are the two types of failure possible, and with the body dimension B by 2h and F, we can able to resist some resist from overturning and skidding. Okay, so but we cannot expect all the time to have a B by 2h in that ratio, because V and G is not in our hand, right? R can be in our hand. Okay, we cannot ask this type of vehicle to always travel in this speed. The speed is a variable quantity. B is fixed, H is fixed, and R is also fixed. Okay, so we cannot ask all the vehicles to fall in that ratio, and to friction can be provided, no issues. Okay, friction can be provided, but to avoid overturning, we cannot always ask the vehicle to come in that dimension and this one. So as a highway engineer, we can also support to avoid the overturning. Okay, so I will show you how we are going to support to resist the overturning. We are going to introduce a term called super elevation. Okay, so we can introduce some super elevation. We are going to elevate the surface, something like this. Okay, we are going to elevate the surface by certain amount, such that we are going to support the vehicle will not overturn. Okay, so this is an introduction of horizontal alignment. Okay, so we will see the story related to super elevation in the next video. So thank you.